I'm back in North America after having flown from Sydney, Australia yesterday via Hawaii to the USA. And what I do when I'm flying, I always try to think of an experiment that can demonstrate Earth's curvature. And one comment I see frequently posted in Flat Earth channel videos is that pilots don't have to factor in the Earth's curvature. Now that is just complete nonsense for many reasons, but one area we do have to factor in the Earth's curvature is when operating the airborne weather radar system to map ground features. And this screenshot was taken about 250 nautical miles out of Hawaii. We were still at 45,000 feet in the cruise, and you'll see on the diagram, the bottom left-hand corner here in green, the weather radar had zero tilt, so it was looking straight ahead. Now you'll notice Hawaii itself, and over here where the island of Kauai is, you can't actually see them on the radar at this point with zero tilt. However, if I tilt the radar down 3 degrees, so now tilted down 3 degrees, you can see both the terrain of the mountain of Honolulu and also Kauai. Okay, so very clear evidence there that a zero tilt does not see those mountains, but 3 degrees down tilt will see them. Now let's have a look at how the radar operates and just compare some of the calculations for a flat Earth to see whether the radar should actually be able to see them. So again, I said it was about 250 nautical miles out of Honolulu. I plotted the position on my ForeFlight app. We were before Barker, and the route was taking us via Carp and Apaka into Honolulu, which is fairly common when we're coming from Australia. What I then did was just take a line straight from the position where the screenshots were taken to the top of the mountain in Kauai. And if we look at the flight plan calculation, you'll see that's giving us 252 nautical miles. So that's what we're going to have a look at when we look at these calculations. Now, looking at the island of Kauai, the mountain, see point number 7 there, you'll see that it's 5,243 feet high. Now, if we look at the Earth curve calculator and we take an altitude of 45,000 feet and a target distance of 200 miles, you'll see there should be about 600 feet hidden. So plenty of the mountain should still be visible. Now let's have a look at how this radar operates. The radar beam, even when the radar has zero tilt, has a vertical angle of 5.6 degrees, okay? So that's 2.8 degrees down and 2.8 degrees up. So even with the radar beam at zero tilt, we're still capturing features on the ground. Now, 290 miles away, we should be able to see those mountains if the Earth was flat. From 45,000 feet to the base of the mountain, 290 miles away, represents an angle downwards from our eye of 1.7 degrees. We can calculate that by using the arctangent of 45,000 divided by 290 miles times 5280 feet, and that gives us the 1.7 degrees downwards. Now remember, the radar, even in zero tilt, is looking down 2.8 degrees, so why can't it see the mountain? The mountain is 1.7 degrees down, that's the base of the mountain, and the radar is covering 2.8 degrees down, so on a flat level Earth we should be able to see that mountain with zero tilt, but we can't. We can only see it when we tilt the radar down 3 degrees, okay, because the Earth's curvature is causing that mountain, even the top of the mountain, to be greater than 3 degrees down from eye level. That's why the radar beam looking at 2.8 degrees down can't see it. That's why we have to tilt the radar down. So yeah, we absolutely do factor in the curvature of the Earth when we're flying aircraft, especially using the weather radar to map ground features. You'll see zero tilt, you can't see the ground. 3 degrees tilt, you can see the ground features. Obvious evidence of Earth's curvature.